Hello and welcome to Python Programming Complete course. This is part 11, Error and Exception Handling in Python. In this video, we will discuss error and its types, what is an exception, different types of standard built-in exception, and how to handle exception while programming in Python. When we write and execute our program, we come across unusual conditions or abnormal conditions. These are called errors. Error disrupt the normal flow of the program. Errors are of three types: syntax error, logical error, and exception or runtime errors. Syntax errors are the error that occur when incorrect format is used in writing a statement using the programming language. Example, missing comma, colon, or a keyword which is used as a variable, incorrect indentation, etc. They are detected at the time of program execution and is pointed out by the interpreter. For example, in this program, there is a syntax error. If we execute this program, we will get a error, that is syntax error. And what is the error? We have missed the parenthesis in this statement. If we execute it again, we will get no error and the program will work properly. You could see. Then we have the logical errors. They are the errors in the source code that produces incorrect output or may disrupt the program. Example, division by 0, index out of bound, file not existing. They are detected at the time of execution of the program. Then we have exceptions, which can be defined as an unusual condition in a program that result in the interruption of the flow of the program. They are the runtime error. There are different types of standard built-in exceptions like name error, index error, syntax error, indentation error, end of file error. Then we have IO error. Now, while we are programming, we will take up different examples and see what are these errors. When an error occurs at runtime, an exception is raised in Python. The program stops execution and the rest of the code is not executed. Python provides a way to handle exceptions so that the program is not interrupted abruptly, and some specific code is executed when exception occurs. This is called exception handling. This could be understood with the help of this program where we are accepting two numbers from the user and we are dividing those two numbers and printing an answer. If we execute this program, we are asked to enter a number. The first number is 10, the second number is 5, and we have got an answer 2. And last line number 7, it is also executed. Our program is done. Now, if there is an exception, there is an error in my program, then it will be halted and rest of the line, it will be halted at that particular statement and the rest of the line is not executed. Same program, let's run it again, and this time we will provide different input. Say I provide 0 as the divisor. We got an error. Our program is halted. 0 division error we are getting. And this last line, it is not executed. The program is being terminated. The error message that is shown when an exception occurs during the execution is called the traceback. This is this lengthy message which appears when the program is ended due to an exception. This is called a traceback. It displays the name of the function, the line number where the error occurred, the name of the exception, and a brief description of the error. Let's see another example where we'll get an error, the name error or the name error exception. If we execute this program, we are entering a number, we are entering another number, and this time we are getting an error, name error, number 3 not defined. We are having only two variables, number 1 and number 2, and we are dividing number 1 with 3. This variable is not defined in a program. All exceptions inherit from or are instances of base exception. This is the base class for all built-in exceptions. Let's see one more exception, index error. In this program we have a list and we are trying to access the value at index 8, and let's see what error it will give me. Index error, list out of range. There is no index positioning as 8 in my list. In Python, exception can be handled using a try statement. The critical operation which can raise an exception or the program have some code that may raise an exception can be written in the try block, and the except block contains code that handles the exception. We have an example program where we are trying to open a file in read-write mode, and then we are writing using write method we are writing some data in the file. Let's execute this program. You could see we got a exception, file not found, an error, no such file or directory exists. So this, we are trying to open a file which does not exist in read-write mode. In real life situation, if we are working with file and we are trying to read or write a file which read a file which does not exist, then we get such kind of errors and a program terminates abruptly. To handle such kind of errors, what we can do, we can write these problematic code inside the try and except block so that our program does not terminate and some statement or some code is executed which handles those exceptions. We have another program, the same code is being written but inside the try and except block this time. Inside the try block, that using the try keyword followed by a colon, inside the try block we have written a code which may raise an exception. That is, we are opening a file in read-write mode and we are trying to write some data inside it, and inside the except block we'll come to this in detail. As for now, just understand that we use the except keyword followed by the exception which we are looking for, which we are trying to handle, and a semicolon, and inside the except block we write what we want to do or what statement we want to print, that is written inside the except block. So if this particular file which we are trying to open, it does not exist or somehow it could not be opened, then the control will be passed in the except block and whatever statements are written there, it will be executed. Let's execute this program. See, this time we are not getting an exception, we are not getting an error, file not found. What we got is error, cannot find file or read the data. That is, since the file is not been found, it does not exist, we are getting this error message. So we can use try and except to handle exceptions. In this program, we have a try block inside which we have two variables. They are assigned some value. We are doing a division, and two except blocks. The last one, it's a generic except clause which can handle any kind of exception, and we have another except block where we are trying to handle arithmetic, all type of arithmetic error. So this is a base class for arithmetic errors. Any kind of calculation errors that arises, zero division error, it will be handled by it. It will print out error in calculation. So in our program we can have more than one except together with a try block. Let's execute it. You could see variable not defined. It is giving me an except clause. It's generic one. It is come inside the generic one. Variable is not defined. If we change this to y and then execute our program, you could see this time it is giving me error in calculation. It's an arithmetic error, it's a zero division error, so it is giving me error in calculation. Now depending upon the exception, that particular except clause will be called and the code will be displayed. Now in this program, you could see many except clauses being written. You have the IO error, which is a base class for IO related errors. We have the zero division error. We have the end of file, if you are trying to read beyond the end of file not found. Now these are all the different kinds of exception which arises if there is a problem in a program, so we are trying to handle. Now this one we are trying to print variable x. So the last one we have written except exception, which is a common base class for all non-exit exception. So any kind, this is the base class for all the exceptions. So in our program, if we execute this, we will get error in our program. So this is also one way where we are trying to handle different types of exceptions. So you could write as many except clause as you want in your a specific exception in your program. Executing this program, you could see an error in the program. If in the same program we make some changes and we write something like some other statements, let's add in some more statement. Let's just comment this and add something like print 10 divided by 0, and let's save it and execute the program. You will see division by 0. This time it has raised this exception, division by 0. Let's again comment this line and add in some new data. Say file new equals to open. We are trying to open a file, say xyz, and let's see what happens. Let's save and execute the program. Input, output, error. This time we are getting this error, this one. For input output, this file does not exist, so we are getting this. You can use the else keyword to define a block of code to be executed if no errors were raised. Till now we were using try and except keywords on these two blocks for writing a code and to handle the exception. We can also have the else keyword, the else block, where we can write the codes which will be executed if no errors occur in a program. For example, we have two numbers, we are trying to divide them, and if we have a zero division error, we will execute this particular except clause. If we have any type error, different types of calculation, then this will be executed. If no error is in my program, then the else part will be executed. Let's execute this program. You could see no error in my program. 10 is divided by 2 and we are getting 5.0, and the last line done, it's been printed. If we make changes, we change this value to 0, then else will not be executed. Only this except clause, you could see exception is being handled, cannot divide by 0, and the program has ended. If we again make changes to our program, we assign this as 2 and we try and instead of writing this, we write let's comment this line and let's write print x divided by str, and then let's divide by a string type of value, and let's print the answer. Let's see what happens. Now this time type error is being raised, different data types for calculation. We are trying to divide an int with a string type of variable. So it has resulted in a different type of exception. Together with try, except and else, we have something known as finally. The finally block is always executed before leaving the try statement, whether an exception has occurred or not. For example, in this program we have try, except and finally. Now finally is generally used to release external resources like closing an open file, GUI, that is your graphic user interface, or disconnecting from any connections or network. So in this program we are trying to open a file in write mode. We are writing some data to that particular file. If the file could not be opened or any other problem, we have a generic except clause, file not opening, and in the finally part we are closing the file and printing a statement file close. Now sometimes it happens if we have opened a file and we are not closing it, then sometimes the data is not written in the file if we have not closed the. So it is always a good practice to close any open file before leaving the program and to release that space. Let's execute this program and see. A file is being opened in write mode and we have written something in that file, and finally in finally passed we are getting file closed. Let's see if a file is being created and data is being written to it or not. You could see Python being written in a file. Except clause with multiple exception can be used to handle many exception blocks in a single except. For example, in this program we have a try block, we have an else part, and except clause where we have written different exceptions in one except block using in the form of a tuple. You could see zero division error, keyboard interrupt, name error. This is also a way of writing the multiple exceptions in a program. So any kind of error which is there, it will be handled. It could be handled in this manner as well. Let's execute. You could see arithmetic or name error. Division by 0 is there. If we try and print a variable which is not there, then too it will come in this same except clause. We will have a name error. If the program runs successfully, we have the else part for that. An exception can have an argument, which is a value that gives additional information about the problem. For example, in this program we have try and various except clauses for handling different types of exception. We have IO error, zero division, and so on, and the base exception class where we are having an argument, and we will print that value in this print statement. So any kind of error which is occurring, any kind of exception which is occurring, we could print using the argument to get, which is written in this manner, except exception as arg. Now arg could be any variable. You could have a, b, c, x, y, z as per your choice. Let's execute this program. You could see error in program, this statement, and the argument which is name x is not defined, which is coming because we do not have this variable. This is from the actual exception which arises, name x is not defined. So if we want to print something like this, or if we want to use the arguments together with exception, it could be done in this manner. Till now we have discussed standard built-in exception and how to handle it. An exception can be raised forcefully by using the raise clause in Python. The raise keyword is used, followed by the exception and an optional argument and traceback. Let's see how we can do this. Say in this program, in the try block, we are taking an input from the user and we are checking if it is less than 1. So we are forcefully raising an exception together with an argument. We are accepting an argument, the same variable where we are entering the data, and in the except block we are writing value is less than 1 and the argument. Now let's execute and see. We are forcefully raising an exception. Enter a number, say -9. So value, it is giving me value is less than 1, -9. Again let's execute it, this time 7. Nothing happens, no exception is being raised, and the program ends because we have not written the rest of the code. So we can forcefully raise an exception using the raise keyword. In this program we are accepting a year from the user. We are checking if it is less than 2000. Then last time we were using the base class exception in the previous program. This time we are using a value error, that is inappropriate argument or value if it's an incorrect value. In this, if a value correct value is being entered, we will print valid year of admission. Otherwise the raise will forcefully raise an exception and it will send to except block where this particular statement invalid year of admission will be printed. Let's execute and see. Enter the year of admission, say 1998. So it is giving me an answer, invalid year of admission. If we execute and this time we write 2002, it's a valid year of admission. So either we can use the exception class, base class, or we can have any other inbuilt exception used with the raise keyword. Till now we were talking about all the standard built-in exception and how to handle it. Python also allows us to create our own exception, that is user-defined exception, by deriving classes from the standard built-in exception, which we will discuss after the video or after we have discussed classes and objects. In this video we did discuss exceptions and how to handle exception, the several standard built-in exceptions. In the next video we will discuss file handling in Python. Hope you found the information shared in this video useful. Stay tuned for upcoming videos and thank you for watching.